Okay, Paul here, and today on the bench I have this incredibly looking Emerson electric fan. It says Emerson Electric, St. Louis, Missouri, and it's a press case fan. Has a non-standard cord. This is not an original cord. This is from like a radio or something, and it's even bent coming apart there. The cord itself is in pretty good shape, but it's not the cord for this kind of fan. So we're going to put a cloth cord on it, and we're going to see how it does. So it's a oscillating fan, bullet case. Tell you a little more about it. Got some messed up back here. The paint is messed up on the back, which is really interesting paint, like metallic paint job. I don't know what's up with that, but I don't know that that's original, but it's beautiful paint job. Anyway, it's got a dent here. I'll try to get that out of it a little bit, as much as I can. And it is a model 77646-SL. Rated at 115 volts, so it's not, again, it's a bullet fan. 115 volts, 60 amps, 60 hertz rather, excuse me, 0.9 amps. And it says, made in the United States of America for alternating current. Emerson Electric, St. Louis, Missouri. And it has a NP number 2841, and then it says 36 on this side. But usually you have to add to that 36, so it's probably a 9. I'm going to make it a 45, but I'm not sure. I'll find out later on. I'm not familiar with this particular model, but it is pretty standard design back here, the way it's set up. The head wire is definitely brittle. It's got to go. So it needs a new head wire and it needs a new line cord for sure. Felt's not bad. Paint's not bad. So let's fire it up and see what it does. I'm going to have to get in front of the camera here a minute and turn it on. I'm going to put it on my current limiting. I'll put it on 3. Current limiting power supply. Bring it up. It would help if I plug my current limiting power supply in. I had to unplug it yesterday. Okay. Try it again. Bring it up. And at 50 volts, roughly 48 volts, we're drawing 0.24 amps. So it's rated 0.9, so we're okay, and that's with my light on. So bring it up a little more. We're at 63, and it's drawing 0.3. Okay, I'm going to back it down, turn my current limiting light bulb off, and bring it back up. Okay, we're at 67, it's drawing 0.4, so we're doing all right. I'm going to bring it up, see where it turns. Okay, it's turning, and it's at 86 volts. It's drawing 0.6. I'll bring it up a little higher. We're at 106, drawing 0.7. 115, it's drawing 0.85. So we're right in spec. And that's on low. On high it's drawing 1 amp, so it does need to be, serviced. It needs to be. We need to get the current down a little bit, but that'll happen just from oiling it and re-greasing it. Okay, so we know it works. So let's try the. We'll put it on the low setting here. Let's try the oscillator. Huh? It oscillates. Okay, so that's what we're going to work on today. That's our project for today. Let me go ahead and start disassembling, and we'll continue. Okay, I'm going to start disassembling this. Unfortunately, I will be in the way a little bit. It's a big fan, so until we get it shrunk down in size, it's going to be a little bit difficult for me to keep it all in the view and not get in the way, but I will do my best. Okay, so the first thing is take the grill off, and get the grill off. That's going to be fun. I think I can get in there with a little adjustable wrench. Maybe. Maybe I can get it out with that. Trick is not dropping things on the floor and having to spend an hour looking for them. That's one. Tight. I have a feeling I'm not turning it. There we go. So they want you to have an easy job of getting the things apart at this point in time. Oh, I remember now. These grills come off differently. I don't think I have to do that. Yeah, that's right. I forgot these things just unlatch. And there we go. That makes it easier, doesn't it? Let's put it with that facing up so we don't hurt the label. Now we can get these off a lot easier. And I do want to get them off anyway because I don't want them sticking in me or hurting, scratching anything when I lay the fan down. Probably should leave one on there until I get the fan blade off. Okay, taking the fan blade off is a little bit tricky. First thing we want to do is take the back off. And there's usually a spot here where you can lock into the armature. There it is. Okay, that's it. We'll go all the way around and make sure. Yep. And it's just a little hole, so we can put a probably a Allen wrench in there. It's pretty good because Allen wrench is tempered steel. Find one that'll fit in there. That one may be too big. Let's try this one. It's too big too. definitely one that'll work. I can get something in it. I'm trying to see when your fingers are in the way. I don't mind getting in there. Let's see if there's a better spot. Yeah. Okay, let's see. And turning the way it turns this way should be the way that tightens it. So it should be, we'll try both ways. There it goes. Yeah, they're fun. But you got to use a little logic. Basically, it comes off the way the blade turns. So the way the blade turns is the way this comes off. In other words, this is the cutting edge. So it turns that way. And that makes sense, right? Because it would turn in that way and tighten as it's spinning so that the blade don't come flying off while it's running. So you do that. Turn it the way it goes when it comes off. And now we can take this off. Place to put these pieces and put that off that way. Just set it in here so it sits in there. Okay. Now we gotta take the motor out. Take these off. I could use that since it's here. And we would use a socket wrench. But since I already got this in my hand, okay, there's the front of the motor. Just checking out the lubrication situation. Lubricated, but it's not the best. We will make it better. Take the worst of it off there so we can deal with it. Coil looks good. Doesn't look like it's ever gotten hot. Well, that's a good thing. And here's the head wire here. And you see it's all brittle. Hear that? So we definitely want to replace it. Well, I can connect it here. I actually don't really need to take it stator out to redo that because this is still pretty solid here. It's just the insulation that's dried up. So that may be a good place to change the head wire. Let's go ahead and get the gearbox assembly off. This is connected directly. I'm going to put there for a minute. Right in the center one. Yeah, looks like it's in the center hole. No, it's an adjustable one. Okay. Okay. You stay there. That's your job. My job is taking the screw out. You're not gonna respond correctly, are you? Simply refuse to do your job. Okay. Yeah. That's off. Put that right back where it goes, and we don't have to find it later. Actually, you know what? I'm gonna leave it off because I don't want it to get jammed any other way. Let's see if we can disassemble the gearbox. Now we'll run one again. We're going to regrease the gearbox too. Since it's showing a little bit of current heat, we don't want that. Current can be a problem. We'll break this one free, okay? Now, just in case there's a screw on a spline, let's take a look in there. Sometimes there's a worm gear that has a set screw inside, and you take the set screw out, and the axle slides out of the worm gear, but I'm not sure the armature But I'm not sure on this one, so we're gonna just be as safe as we can as we go before we break things free. Have to put screws back in, hold them back in place. Yeah, I think this is one of them. Alright, this is one of the small little squeakle. And okay, let me see if I can show you what's going on. Here's the worm gear here. And you see when I try to pull the axle out, it hits, right? It won't come out. So there is some kind of connection there. I'm not seeing a set screw. But that's what I'm going to do, is clean that grease off and see if there is a set screw. This grease is all dried up, and that's why we're going to change it, you see. Pretty nasty. There's the other side of the gear. Let's just stick that in here where it goes. Just like that. Make sure there's no washer down there. No. Okay. Continue checking this. Nothing on this side. Nothing on this side. So maybe that goes out the other way. And that's what I was starting to do by taking this free. See what's holding that on. Yeah. Okay. And you see the dust and dirt in there. And okay, there's a little bush in here. Alright, we set that down over here. And that bushing just goes on that shaft right there. And it's all gummy. All of this is what affects the current flow, all that gumminess. Okay, let me get a clean rag to get some of this stuff out of my way. No, there is a way that comes out. But I don't think I need to even worry about that, to be honest. I can unless I decide I want to take this data completely out, I probably won't need to. Yeah, this unit is so clean inside. I'm looking in there and it's clean inside. The only place it's got dust is right here. Right at the bottom of this coil, and it's so insignificant. I mean, that's it, right? So there's really no reason for me to get in here. This is a low-use fan. And I told it's a young kid that owns it. I told him I would try to do my best to save him a little bit of expense. And it looks like the Lord is blessing, because there's not much in there to clean out. And you do need to oil that. I'm going to have to take that shaft off. See, there's no set screw. Oh, there's a pin in this one, so it obviously comes out from the front. There's a pin that goes right through this one. It holds this on the shaft. And I knocked that pin out. And on this side, it's got this spring. And I definitely don't want to take the spring off. It is pretty clean. The shaft is pretty clean. It's what it's had. It's kept it oiled. It's just the gear that was in the grease and the gearbox that's corroded. And I can clean that from here. Let me take that off and put it in here. I know where it goes. Just clean it off a little bit. It's just a spacer, that's all it is. And I'll clean the inside with a Q-tip a little bit later. There is one washer. So they go together, the washer goes in first. And I already looked in here, and I didn't see any washer in here. Yeah, there is one. Makes sense. There has to be one on each side of that. Okay, there's one on top and bottom of that, right? So we'll clean them and put them back in. And clean the gearbox. So you see, that's what happens to the grease, and that's why you got to do it. See how it turned to rock almost? It's no longer grease. So we would clean this gearbox completely out and re-grease it. You see, the grease is, it's actually not one of the worst ones I've seen. It's just beginning to get there. See, that's no longer grease, it's not moving. So the gears can't use it. They can't pull it in and use it. And what is in the gears, in the teeth of the gears, is gummy. So it's actually doing a problem. And we got a washer there too, so I might as well take that washer out. And that washer goes on there. If I have to change those, I got new washers, I can change them, but I just want to get them out so I can document where they go. And that's it. Now see this? That's all dried up. See that? It's like flaking and stuff. See? There's a flake. Just totally dried up. So that's all going to go. That's where the current is going. So we'll clean that out. But I want to go ahead and do the electrical first before I worry about that. I just wanted to see what was there. Put these oil. Like I said, there's no reason to take the tape out. This is fine. It's fine. It's just fine. Just oil and go back to business. There's nothing wrong with that. So since this is the dry rod part, you hear that, you know that's the problem. And so what we're going to do is cut this. A little bit of it for now. Undo it.
this case is a fine shape. It's just up here. It's just our insulation is right up. Oh, so this cloth is just right up. Okay. Check this way, listen to the shot. Outside into the shot, another way. Inside is always fine to hold on to so you get some of the insulation off. That's why I started up here. If I need the wire, I don't worry about it. Because I'm going to change it anyway. What you do is you untwist the wires as you go. And then we check the condition of wires. Okay. Try not to hit the wires. The wire's fine. There's nothing wrong with the wires. It's just this insulation. And I'm using the clippers. It's a little slower, but it's slower, but it does a better job of staying away from the wires. It's just not a bad thing if I make a little because I'm going to put insulation over anyway, shrink wrap. But I'm also checking them as I go to see how brittle they are and how they feel. Because I'm going to tie onto them if at all possible. And right now it's looking like that's not a problem. Maybe years before these wires are deteriorated. It's just this sort of stuff, right? But even if it's not bad, I can't tear it. I gotta cut it. So that's a good sign too. It's just been in that shape for a long time. I think I'm about where I want to be. You know, I'm getting to the point where I can't really cut it. What you want to do is separate the wires. These spots here where I nicked it. But I'm going to put shrink wrap over it. It's no big deal. But if you separate the wires, as you go, you're less likely to do that. Just find where the wires are, get between them. Yeah, the insulation is really strong, and that's a good thing. Yeah, that's actually a pretty good thing. I think I'm going to leave that alone. Just out of here. I'm going to take a little bit more off. I can do without cutting my fingers. There we go. That's like into the wire. No, yeah, I can't get much further than this. Let's get another laser blade. Make it smaller. Get more control with it. That's better. I can get just a little more right here. Come on. Just a little bit more. Yeah, that's it. Perfect. Now we're good. All right. And there's our head wires, and I'm going to connect right here where I nicked. A lot of work, right? Going through all that for nothing? Well, it wasn't really for nothing. One, it told me that the wire is fine. And two, if I would have started here and nicked it, I'd have been in more trouble. At least this way, I was able to get it where it could be more gentle, and I still hit it here. So now we got to strip this just a little. I don't know if this stripper will work on that. No, probably not. A little bit there. Okay. It's braided wire, so. I did it 16 gauge. And I got cloth hairs. You want to get them out of the way and cut just them and not the copper and snip them off. Yeah. So that you have a nice copper to solder to. Fortunately, they're kind of, they spread out for you so you can see them and just get them out of the way. Yeah, see? Nice copper. But this braided wire that they use has cloth braiding in between the strands, so it's a little bit of fun getting it out of there. And it's 16 gauge, so we go to the 16 and we just do that and take it off. You see that? Yeah. Okay. Alright, let's see. Yeah, it's very fun dealing with the wire, original wire they use, because it's very small, thin grade copper braid. And trying to get the wire separated from the cloth can be fun. I mean, if you cut one or two, it ain't the end of the world, but you don't want to cut out many of them because you don't want to weaken the resistance of the wire. I mean, the solder gun would burn it off anyway, but I like to get it out of there so I know I'm making a good solder connection, at least most of it. And just bend it the other way and it pops out that way, see? and you want about a ½ inch at least of stripped wire. There we go. And see how the spare wire pops out, and you can just cut it out. And of course, I'll be tinning them, right? So you know they're going to be in really good shape when I'm done with that. And that one's done. And this one, I think I want to try to take a little bit more off than I did on that one on that black one initially, so I don't have to fight with it so much. Yeah. Much better. A couple in there. Let go. Okay, I think I got most of that one out. So yeah. I'd like to see the machine they use to weave the cloth right into the strands of that fine little copper. That must be some machine. And the copper is so small that you can't use a match or something like that. You could just shrivel up the copper because it's very small gauge. So you got to physically, with your fingers, separate it like that, see? And then slip off just the cloth. And you just keep moving it around and the cloth comes out like here. It separates itself as you move it. Okay, now you can. We have 3 wires on the stator. We have a red, and a green, a red, and a black, and we're going to measure the green to the black. So we're going to take those 3 resistance readings. So the first one will go from red to the green, and we're getting 52 ohms. So that's 52 ohms. Oh, I'll be back. Okay, so we got 52 ohms from red to green. The next ones we want to do is the red to the black. So we take this off, plug it on the black, and we got 32.7. 32.7. That's much better than the numbers we were getting on a different fan I was doing. All right, and then the next one is the green to the black. And that one's 19.7. And so there's our stator coil windings. The next thing we'll do in a bit is the speed coil, but I don't need to worry about that right now. What we're going to do is run a wire down for the new head wire, and the wire that we have is black, white, and green. So we're going to, for the green, we're going to use the green on the line cord. So this will be the AC head wire, which is basically the same as the line cord. For the red, we're going to use the white, and for the black, we're going to use the black. Now, normally I would use the black for the red because the red is usually the hot and black is hot, but it doesn't matter as long as we know what we're doing. So that's what I'm going to do. And that'll go to the speed coil. Okay. So on the speed coil, we have a coil center tap. And so those wires are going to go to the speed coil. Okay, anyway, we're at this point. Let me go ahead and connect the head wire and we'll continue. Okay, I got the fan back together. I haven't put the covers on yet, but got it wired up on 100 and let's bring it up to about 115 volts. Okay, it is 116 volts. And if I turn it on low, it's running smooth. Of course, the gearbox is off, of course. This is just the rotor and the stator. And so, on high, it draws 0.7 amps, which is rated at 0.9. So by the time I get it together, it'll be there. So 700 milliamps now. Actually, what? 730, figure 735. It's rated at 900, so we'll be fine. Again, it isn't even lubricated yet, right? It's just assembled with new wires, basically, and cleaned out through the whole thing, took the shaft out, cleaned it all off, cleaned off that worm gear. I still got a little bit cleaning to do on it. I just wiped it down, but then I'm going to oil it and put it back together, and that's next. So, if I shut it off, show you the bottom here. Well, not much to see, but the new wires and the coil's been cleaned and reinstalled. The switch, I mean. So, that's where we're at. Getting coming along nicely. I still got to disconnect this and clean it. I haven't done that yet. But just doing the electrical part at the first part. And once I reassemble the motor head here, then I'll pull it out of here and just clean that up. That's just gunk that dripped down there from improper greasing. Anyway, thanks for watching. Alright, I totally disassembled this gearbox and I've already gone through 3 of these. I cleaned off, I'm still cleaning, but you see I scraped all the worst off. This was caked front and back, just caked with that dried glue. Used to be grease. This had some. And the gear, I haven't even cleaned it yet, but you see it's all caked in there and it's dried up in between the teeth. And it's like even after soaking in this, it's still, see how dry it is? This is wet from alcohol because I've been cleaning my blade to get it off the blade, but you see how chunky that is in there. So you got to get all that out of there because that's all old, dried up, chunky grease. And so, like I said, I've been through a bunch of those already. But I just wanted to show you the process that we go through to get the gearbox clean. We clean it out. I mean, we don't just like wipe it with a Q-tip and throw new grease in there. We clean it out. It's got to be cleaned out. And you need to do that. You need to clean all these parts and get them really clean. Grease, dry grease in those gears, like up here, see in that gear, and then in the lower gear, that makes friction, it makes pressure because the gears have to intertwine and they got grease, dried grease. It's like having dirt inside there. And it gets in these teeth and it dries up. And when it does, they don't mesh good. They put pressure on one another instead of being lubricated. They push on each other and crush each other and smash into each other, and that puts all kinds of pressure on the fan motor, which drives the current way high and overheats the coils. So you definitely don't want to do that. Of course, this fan, that stator is in fantastic shape, so going through this will keep it that way, and that's what we want to do. Anyway, I just thought you'd like to see that. Okay, here's the gearbox. You see how clean that is. That's what you want. The top plate had dried stuff on it. I got it off the best I could, but this is a whole lot better. The gears,
The fiber gear had some wear, but I got it clean. And so I'm going to go over it one more time when it dries up a little bit. The stuff I use is safe on it, ain't going to hurt it. And all the little bushings and things are cleaned. Now I clean the inside of the motor housing, so it's ready to go back on. And so, but that's what you got to do. You got to clean those gears. If you don't clean those gears, stuff will stick in there and just wedge between the gears, dried up, and cause problems. I'm going to go over those two gears one more time. You can see how much cleaner that is. That thing had dried stuff in it. I had to pull out a screwdriver, small screwdriver, to get it out of there. So yeah, you got to go over this stuff. Anyway, that's I just wanted to show you what I got before I start reassembling the gearbox. Oh, and the adjuster, I cleaned it all off. Got it cleaned out good and ready to go back on. It now turns. Of course, I can't do it with one hand. It takes some pressure, but yeah, it now turns so you can adjust it easy. You don't have to grab it and try to with all your might. It was so gummed up, but now it turns easy. So everything's ready to go back in. And that's what you got to do to these gearboxes to get longevity on the stator coil. You know, it's a chain effect. And so you got to think of it that way. If you don't get those gears clean, you're putting pressure on the motor. Pressure on the motor drives up the current. Driving up the current overheats the coils. Overheats the coils, can make the varnish come right off the copper wire, and they short out, and that's it. The motor's useless. It costs you a few $100s to rewind the stator. So, you know, now that you got a motor that's hot, the armature gets hot, everything gets hot, and so you want to keep it all clean and do the best you can to get it clean. So anyway, hope that gives you some information about how to clean these gearboxes. Don't be afraid to disassemble them. And just remember where everything goes and you'll be fine. Thanks for watching. Well, here's the fan back in its case, all ready to go back to the customer. It's running fine. There's a lot of air. So anyway, thanks for watching. There's another restored fan.